Assalamualaikum class, very good evening. Today we continue our lecture to chapter 12, implementation model, and this is the last chapter of the software analysis and design. And the time now when I recording this video is 6:44 p.m. Okay, what is the chapter 12 covered? Actually, chapter 12 is an implementation model where we want to describe how the system or software to implement in the real environment. Yeah, one is a software in the server. We call it a component. Using a component diagram, we model it using component diagram, and another one is the system implementation using deployment diagram. So what is the difference between software component and system implementation? The software component is inside the software or the class inside the package. When you look at your previous design uh, where you design your package, which you group all the classes into specific package. So from there, uh, how the software is interact is actually you can visualize it using a component diagram. Yeah, and the system model system implementation is where you implement your system in the real devices in the user side. Yeah, so different software and deployment diagram. It show how your software, your application is stored or saved or running in the hardware part, yeah, of the user uh, server. Okay, this is different. Yeah, component software component and system implementation is different. Software component, you visualize how your software interact each other to accomplish one process, one transaction. For example, you want to process payroll, then you visualize how the payroll started from the UI until it process or calculate the uh, staff or employee salary. This is a component will show in the component diagram. So system implementation is where the payroll system you deploy it, you visualize how the payroll system deploy in the server or hardware side. Yeah, maybe you use a web-based application, so you need to show where you locate your web server, yeah, your DB server, how what kind of network you use. Is it a public internet or VPN and so on. So this is a deployment diagram. So before we go further on the chapter 12, so I just want to recap a little bit on the past lecture. Yeah, so we discussed on high level design and detailed design, where the package notation is used in a lot of modeling. Yeah, in the modeling of high level of your design, right? So we use package diagram to show the structure of the system. So when you talk about high level design, normally you will use a package diagram. Yeah. Then we continue to detail design for describing the class and method, yeah, on how the software requirement should be implemented, as well as giving the programmers a blueprint to follow. A blueprint to follow means how the application will work, and then the programmer understand the blueprint, the logics, then they able to code the program. So the blueprint is written in the format of algorithm, normally in pseudocode. They call it program description. So remember that when you do the high level design, you use a package diagram. So when you continue to the detailed design, you will use the algorithm. You describe the logic of the application using pseudocode or algorithm in English like. Okay. Then after you finish, you complete your high level design and low level design, so you need to model the implementation model. Yeah. So this is chapter 12 covered. So chapter 12 covered how or a way to visualize your software, that running in the actual server, and also visualize the implementation structure, the how you implement your software in the real devices or location, geographical location where you put your server. Okay, so surely this will be modeled using two type of diagram. So how you want to visualize your software process, so you use a component diagram we discuss shortly. And then how you want to deploy how you want to model a system implementation structure on the piece of hardware, so we use a deployment diagram. So first we go to the component diagram, so where we use this component diagram to model the software component structure. So the implementation model uh, describe how design model element are implemented in the term of component. Okay, normally before you start to design your component diagram, so you need to understand the notation, the syntax of the component diagram. One is a package. I think you're very familiar with a package. And then this is a component notation, a physical and replaceable part of the system that conform to and provide the realization of a set of interface. Okay, so this is a notation of interface. Uh, the interface notation show how the input and output uh, will be received by this component. Yeah? When you want to use this component, so you need to talk with this component through the interface. Like you want to communicate with your friend through email, so you communicate through you need to compose your email. Yeah, you have to uh, put the address, and then you put the title and the contents. So same with the component diagram. When you want to use this component, so you need to provide the parameter. So this is called interface. Yeah, and this is a relationship, whether you use association or dependency or realization. Okay, so So this is a notation of the component diagram. Okay, before you want to start to design the component diagram, you need to understand the notation. Okay, so the component structure represent a modular, deployable and replaceable part of the system that encapsulate implementation and expose a set of interface. So remember, when you want to design your component diagram, so you need to design also the interface. Interface is like a parameter. When you want to use, let's say you want to instantiate some of the class, so you need to pass the parameter, right? Let's say in the bracket, so you put name, ID, IC number, or etc. Then you instantiate the class, and then the last parameter may be the return value, right? So this is some sort of interface. Okay. uh, the component diagram is a concern with modeling the structure and dependencies of component in the implemented system. So component diagram normally illustrate the piece of the software, embedded controller, and etc. A component diagram has a higher level of abstraction than a class diagram. So normally, uh, when you discover your class diagram, then you need to group. You group your class diagram into package. And normally the package is become a component. Let's say package A, and it become a component A, which consists of a lot of class inside the component. Okay, usually a component is implemented by one or more class. So there are building blocks, so a component can eventually encompass a large portion of a system. Okay, when you want to complete your system, of course you have module, sub-module, and etc. This is the meaning of building block of the component. So I'll give you an example of the component diagram. So this is a sales application. So this one is a UML1 notation. Last time we use UML1 version 1. They don't use this compound. There is no compound. So now we have a UML2, and the component notation is same. So we go to the figure 2. So let's say this is a sales deal. Sales deal consists of various UI, and the sales deal is submit, and it go to the is sent to the sales server by creating the sale message. And normally the sale message we go to the message queue. So let's say the server is down, so the queue will keep trying to send to the sales server. Once the sales server is up, then the transaction is still submitted to the server. So this is a design of the application. If your system design is not included for message queue, then forget it. Okay, so in sales server, you look at the sales server, there are three components. Maybe your application got more than that. So this is like sales server, like a package, and this is like a detailed classes. And after the sales server receive the request, then they process it, and let's say it involve the payment or bill. So the bill transaction or payment transaction, we go to the accounting component. So this is another component. So accounting system is a big system, so there are a lot of sub-components under the accounting system. So this is a structure, how you visualize your system using a component, where you show that the process getting done before they proceed to another component to complete for one transaction. Okay, so this is a component diagram. Okay? You show how your software work in internal server. Okay, so you want to know the process, so you can read the explanation of the diagram. Okay, so we go to the component diagram, when to use the component diagram. So normally component diagram will be used when you dividing your system into component and you want to show their interrelationship through interface, or you want to break down your component into lower level structure. So I give you an example. This is a package organized uh, by you before you go to the implementation model. So this is a package that you organize. So inside the package a lot of class, class, and inside the class of course they have a methods. So this is a very organized package you designed before, and actually each of the package you need to visualize the component, how the component, how the process of your software work using this package, using this component diagram. Yeah, understand class how you relate your package diagram to component diagram. So maybe this is one of the package that you elaborate into the component diagram, because one package got a lot of component inside the package. Okay, so now we go to deployment diagram. So deployment diagram show a system physical layout. Yeah, normally it reveal which pieces of software run on what piece of hardware. So normally deployment diagram are really very simple but short diagram. Yeah? So the main item on the diagram, they are not connected by communication paths. So I show you the notation. So this is the deployment diagram. They got nodes and association. Okay, so node is a physical element such as a web server, DB server, router, yeah, memory, and so on. And the association is a structural relationship that describe a set of link. So let's say how you link between one server into another server, how you link from web server to the DB server. So you use the association. So deployment diagram, normally the node is a very important part, contain artifact, which physically contains the file, exe file, dll file, or jar file. So you can show artifact either as a class boxes or listing the name within the node. Okay, so you can list all the components, the file component inside the nodes. Yeah. So communication part between node indicate how things communicate. So you can label these parts with information about the communication protocol that are used. So this is an example of the component diagram, a deployment diagram, sorry. A sample of deployment diagram with UML. So this is a node, web server node. So inside the nodes, you can insert the software component here. So this is a student administration module. in the format of Java file .gsp for example, or exe, or you use C++, .ccp something. Okay, this is a application server, consists of a lot of components, software component. Okay, this is a DB server. So this is another server, mainframe server for example, so another node. So how you want to link between nodes? So this is a communication through RMI, through the JDBC, through message box. Okay, this is an example of application. It's a work group application. So it use what they call it. It use the internal network. Yeah. So no internet use in this application. So if you use internet, then you need to show the internet nodes and how it communicate each other. Okay, so another example of deployment diagram is this one. So this is a deployment diagram without UML. This is a uh, freehand diagram, how you show your application, uh, implement in the real environment. So this is a Dr. A for example. So in their PC, so each of the PC of the doctor have to install the Java SDK for example, and each of the PC have their own uh, database. Yeah, so this is called decentralized data. Yeah? Each of Dr. PC got software component, and it communicate through SMS to the server, and this is a mobile network operator, a public network. If you go to the data center, for example, you go to the MOS data center, and we have a health record management system, and also the SMS server, which hosts in the one big server. Okay. So this is one of the deployment diagram without UML. So in the exam, so you will ask whether you need to use UML notation or without UML. Okay. So if you ask for UML using the UML notation, so you need to use the UML notation only. Yeah. Don't use this freehands of diagram design. Okay, use the UML notation. If the question is never asked for using UML, so you can describe using this one. Okay, class. I think the deployment diagram is very simple. You show how your system is work in the real environment or real devices in the user side. Okay, so when to use the deployment diagram? So you when your application is very complex, you involve your system involve multi-region, so you need to design the deployment diagram. Okay, so in summary, component diagram provide the overview of the application structure in terms of processes, relationship, and interface, and deployment diagram provide the overview of software and hardware that could be deployed in a real machine. Okay, class, thank you very much. See you later. Assalamualaikum.